In this video we have the integral of 12 over x to the 7th plus x to evaluate. And a first glance at this would suggest the method of partial fractions. We factor out an x from the denominator, get x to the 6 plus 1. X to the 6 is a cube because x squared to the third power gives me x to the 6, and of course 1 is a cube. So I could factor that into x plus 1, or I should say the sum of the cubes, which would be x squared plus 1. And then the other factor would be x to the 4th, this first term squared, minus the product of those two, x squared times 1 plus 1 squared. So the first factor here is x, and then we have x squared plus 1, irreducible quadratic factor. But then I can have an x to the 4th. So I'd have to find a way to factor this into two irreducible quadratics. And you might be able to do that, but I'm going to scratch this method here. I would suggest a substitution, U-substitution. You can pause the video and try it, and then I'll be back. Okay, so here's what I'm going to do. I'm going to factor x to the 6 from the, or I should say, x to the 7th. X to the 7th from the denominator. This will give me a 1 here, plus, and then here, in order to get the same thing back, I'd have to have an x to the negative 6. And then this would be equal to, and then I'm going to rewrite this, x to the 7th here, so I'm going to take it to the numerator, which I can do. Just change the sign, just multiply the numerator and denominator by x to the negative 7. I get x to the negative 7 here. The denominator, I'm left with 1 plus x to the negative 6. And of course, with the U substitution, the key is you're looking for a derivative of some quantity. It could be a denominator, it could be an exponent, or something else, so that the derivative of that expression appears in the numerator. So notice here, the derivative of 1 is 0. The derivative of x to the negative 6 would be negative 6, x to the negative 7, which is what I have up here. So here's my substitution. U will equal to 1 plus x to the negative 6. Then du will equal to, derivative of 1 is 0. The derivative of x to the negative 6, again, power rule here. Negative 6 times the coefficient will give me a negative 6. Subtract 1 from the exponent. Negative 6 minus 1 would give me a negative 7. And then this would be dx. So solving for dx, I get dx is equal to du over negative 6 x to the negative 7. Du over negative 6 x to the negative 7. Then we continue over here. This will be 12 x to the negative 7 over, and remember, 1 plus x to the negative 6, that's your u. So put it here, a u here. Go into the transformation then. I'm converting the original integral into one involving u instead of x. And then instead of dx, I've got, replacing that by du over negative 6 x to the negative 7. X to the negative 7, x to the negative 7 here, to cancel, divide out, and then negative 6 into 12 is negative 2. So I got negative 2 over u du. So you could bring the negative 2 out in front if you want. So it's basically it's the integral of 1 over u du times the negative 2. So that's your reliable formula here. Absolute, or a natural log I should say, of absolute u plus a constant of integration. Then we continue over here. All we have to do now is just go back to the original variable. So we got -2 natural log of u, but u is 1 plus x to the -6 plus the constant. Here's your answer. -2 natural log of 1 plus natural log of absolute 1 plus x to the -6 plus a constant. And of course in this case I can rewrite this as 1 over x to the 6. Since I have an even exponent, I really don't need the absolute values here. So I could put parentheses. Thanks for watching. We'll see you next time.